Welcome. As you said, we're going to talk a little bit about developing products for the Internet of Things. And this is a talk I've been not wanting to give because I didn't think it was actually necessary. And then I went to a couple places and talked about this, and I realized that, shit, we need to do this. Can I curse? It's on video. I hope I can curse, because I curse. So don't be scandalized. Anyway, I used to actually got this idea from, I had a friend over, and I had this really old house from the 19th centuries, and the doorbell was, you know, one of those old, but you all heard them. And I could mute this with my phone. So I stick on the phone, watching a movie, it doesn't sound. And he was like, mind blown. So, what are you doing? And it's like just muting my phone, it's simple stuff. And this is one of the sharpest, this is one of the best web developers I've ever seen in my life. He knows stuff that, he learned a Qt framework in like a weekend, and he couldn't figure out how to make a computer actually do something with the physical world. And the problem is that actually doing something with the physical world is super simple. I can do it. The problem is figuring out a good thing to do that you can actually sell. So I thought, okay, I'll tell these brilliant people in this room how you do it. So you can figure out a good idea, and when you do, you can hire me. Okay? Excellent. Like I said, my name is Karl-Henrik Nillson. I work for Society, which is a lovely company. If you don't mind anybody but the French getting your company name wrong. Oh, I'm sorry. Actually, Neil from this morning, he broke my presentation because he also gets the company name right. So it's everybody but the French and Neil. Enough about me. Oops. Anyway, what I want to give you with this talk is that you can walk away here with the feeling that you can do anything with electronics, with a computer. You can connect it to anything in the world. You can actually make it change something physically. That will be enough. But hopefully you will also want to buy stuff or use the Raspberry Pi you have and develop it with something else than JavaScript to actually make a physical change in the world. And I've had this feeling since I was a small child. I've been able to play with anything, do anything, try anything. And I've had this because a few words my father once said when he was really, really in a hurry, and he just couldn't be bothered to help me. And he said, "There's nothing you can break that I can't fix." Let's just say I've proven my father wrong a few times this. But I've also learned a lot. You learn a lot by breaking stuff. You learn a lot about breaking code, breaking tests, and you learn a lot about breaking hardware. It's not the first doorbell, but this one lived. So you're gonna do that. You're going to do like things that are going to break. And well, that's it. But it's not expensive stuff. Most of these things are cheap to buy, cheap to get. Well, you can start off with them easily. So I would like to start by defining what a smart object is. I would actually assume that most people in this room knows what a smart object is, but just to make sure. A smart object is anything and everything you can touch. Is that coffee cup? Is this stairs? Is every chair in this room? It can be anything and everything. It can be a cargo, a plane, a shipment, lots of shipment inside a plane. That's also a smart object. Smart objects inside smart objects. It can be anything that you can physically touch. All of you in this room have a smart object in your pocket, or well, like 99.9% of you, because you have a smartphone. Do you, by the way, know that smartphone developers are out to get you? Apple hates you. Android developers too. Windows all hate you. You know why? Any guesses? How many people in this room use your smartphone as an alarm clock? Hands up. Okay, like everybody. How many in this room has once been delayed to a meeting because your phone did not check traffic, nor did it tell you that when you set your alarm clock for 9, you actually had a meeting at 8? You have a meeting at 8. Why can't it check your calendar? Wake you up early. Fuck what you said. Well, it's something, and this is something the smart object should be able to do. I'd like to show you a little bit more before we continue with the demonstration about how we could actually convert, let's say, one of these chairs into a smart object. And since I'm Swedish, I've selected an IKEA chair. I hope I get royalties. So The first thing we would like to do when we're creating a smart device is to give it a unique identity. A unique identity such as an IPv6 address isn't really implemented all that well yet, but when the IPv6 is implemented, we will be able to address almost any need for addressing in the physical world. That means that all the chairs in this room could actually have a physical address. Well, the next thing we need to do is actually give it a brain. We need some way to know how can we connect to it, how can we talk to it, what's actually happening. If it doesn't have a brain, it can't do anything. It can't process code and tell us stuff. So we need some sort of thinking device. And lastly, we would need a sensor of some sort, an AST detector. We need a way to notice if somebody's sitting in me, like a pressure sensor. We would need some way to know who is sitting in this, and this is an authorized sitter, or is an unauthorized sitter sitting in my chair. It's an IKEA chair. I'm sensitive about my furniture, okay? So when we have all these things, we can create a way to know, well, is the person sitting in my chair an authorized sitter? And is he sitting there? But what if he's not? Let's say we have an unauthorized sitter in our chair. It can instantly inform me wherever I am. If I'm at this conference, my phone could just, oh, hey, somebody's sitting in your chair, do something. And I can, well, a small electrical current, for example. So you see, anything we have can be made a smart device. Doesn't have to be a chair, but my example it is, because I'm not perhaps smart enough to come up with a good example where you would actually be able to sell it and make money. But I hope you guys are. And a lot of people have been telling me when I go out and say this, like, I hope you guys are here to talk about it. And they say, yeah, but you know, the internet thing haven't been around for that long. They talk like that. For some reason, all talk like American marketers. But the internet haven't been around for that long, or we don't know about it, and whatever, whatnot. And this is total bollocks, because the Internet of Things have been around since 1991. It was coined the 6 Web Framework in 1999 as a direct-to-direct item communication, and Kevin Ashton coined the term Internet of Things back in 1999. So I mean, the Internet of Things isn't coming. We have smartphones, we have connected devices, but so it's here. And this may lead us to ask, actually, why are people suddenly now starting to talk about it? Why did people invite me to a conference to talk about this stuff? Why are you actually in this room listening to a talk about a technology that's as old as 1999? Well, it has to do with hype. Anything you don't talk about don't exist. So back in 2012, people were talking quite a lot about IoT, because we had a gradually small increase of things that have been progressing. Then something happened. People started talking more and more and more about it. Microsoft released an IoT framework. Apple did the same. Google started talking about it. Google Glasses came, if anybody has one. Stuff like that. And suddenly it fivefolded. We have 5 times the amount of news coverage on IoT devices. And suddenly I could get invited to conferences. So how much money do you think IoT... What is this number, by the way? It's not a country's budgets. This is how much money IoT has occurred since. Do you think since when? Any guesses? How much money did it take for the IoT industry to make this revenue? Since the 2000. It's an excellent guess. This is in January 2014. My guess, when I first heard about this back in 2012, was 19 billion. I was wrong. Yahoo was wrong too. They thought it would be 20 billion. This has increased in such a speed. We don't have enough understanding about technology. Anybody can come up and start working with this today. And people have developed lots of stuff. Super, super cool stuff. Do you know there's baby monitors that you put in the crib? It analyzes how your child is sleeping. It looks at, okay, is he moving? Is he lying still? How is his breathing and pulse? Stuff like that. and it logs this to give you an indication about in 42 minutes, your child is going to wake up. He's going to be happy because he slept rather well. Any parents about here is going to be like, where can I buy this? But it also does more. It actually analyzes the temperature where he sleeps the most efficiently, and can actually tell you that if you move your child to a room that is 2 degrees colder, he will sleep much better and be much more happy. This is actually not a fantasy of mine. This is a $250 product you can buy called Sproutling in USA. So how many smart devices do we have on this image? Any guesses? Come on, shout it out. I'm sorry? 4. Which ones? I think it's a book. I don't know. I like 4. Let's go with 4. We'll start with a lamp. What's smart about a lamp? Well, it can be anything. It can be voice activated, controlled by a lot of other smart items in the house. When it's time to wake up, the lamp could like start slowly and wake you up more nicely to a slightly more lighter room. I mean, the clock, of course. The clock could actually be a smart clock and not out to get you. It could ask your phone, does he actually have anything booked? Okay, set his alarm clock for 7:30. He needs to be at work at 8:30, but I just checked the traffic, and the traffic is horrible. He needs to be up at 6:45. All this is actually not even hard to do. It's just something we can think about doing. Also, the alarm clock could, also the bed could be smart. The bed could be analyzing your sleep pattern exactly like the baby monitoring is doing. It can check like, okay, you're sleeping, well, not entirely optimal, but your wife is sleeping really nice, and that's all that matters to me. So what it does is actually checks that, okay, your wife is not sleeping optimal, you're sleeping like a baby, but your wife really doesn't like this. She's 50 and in menopause. So I'm going to go ahead and lower the temperature to 10 degrees. Well, you could do that. You could actually enable anybody in the room that has the highest priority to sleep great. Is it your child, yourself, or your wife? It doesn't matter, but it could actually talk to a smart AC unit and tell it, hey, I'm not sleeping optimally, do something about it while you're sleeping. I don't think this is science fiction. Most of this stuff already exists. This exists smart AC units. It exists smart bed, at least smart baby monitors. This is stuff that we actually could build, we actually could market and sell if we wanted to. And you have more stuff like that. You had smart gas sensors, smart fire detectors, lots of smart stuff that we could build with. But okay, this is small scale, and this is a consumer market product. Consumer market isn't interesting to everybody. It's also hard to develop technologies for consumer markets. So we're going to scale it up a little bit. Meet San Francisco. That's a bit of an upscale. San Francisco has 28,000 parking spots. Yet, it's not really easy to find a parking spot in San Francisco. So what they did, that 1/4 of all the parking spots in San Francisco was connected to an IoT device. So that you can pick up a smartphone app and see, okay, 250 meters in front of me to the right, there's an available parking spot. You go there and you park. And when you park, you can just take up your PayPal account and say, okay, pay for parking. When your time runs out, the road automatically identifies that you're still in that parking spot. So it can notify your app that, well, hey, you need to pay more, okay? Or it can notify a meter maid, go over there and find this man. So this has enabled San Francisco to have a lot less meter maids, a lot easier to park, and a really cool project from people like me to talk about San Francisco. So it's good for the industry of travel, to get people there. It's good for they have to pay for less meter maids, and it's good for the people of San Francisco. I really like this. I really like this example because I think it's super cool what they've done, and I wish they would do it in a lot of more cities. So does this sound like complicated stuff to you guys? Because this is actually super simple, and that's the secret. So we're going to go scale it down to like super low levels. And if you think that this noise, when I was building this, did not annoy my coworkers, we had a few brief moments of violence, but we worked it out to my disadvantage. But we're going to scale it down, and I'm going to show you how to take a really stupid thing like a doorbell and make it a really smart thing like a smart doorbell. So the first thing I'm going to do is going to take this button here, as it was once, pure and unaffected. And we're going to make a hole and break it up, which we did. So we broke it up, and I spent a not too proud moment trying to figure out how to actually access the microprocessor in this, which is a really small, really simple product. And then I realized that, hey, I can just cut the resistor, and that's the button. I can just press the button with technology. I don't have to talk to the microprocessor. I can make this super, super simple. So that's what we did. We cut the resistor to the button. So we put a transistor there. With transistor is basically just the digital version of a button. You can actually give it 20 millivolts or milliamps of current, and it will push the button. There's a blog post on my blog how to use transistors if you're really, really new to technology. So don't worry about it. And then we added a cable, this nice little thing. I did this so I could actually have the processor free, so you can actually see that what we're doing. Otherwise, we would have put it inside the box, of course. And then we broke the transistor in experimentation. We're trying to debug something. We had like a lot of signals going on, so every half an hour it would bing bong, and we tried to figure out what was going on. And I was really encouraged by my coworkers to find out what was going on. And I discovered it was a faulty transistor, was taking leakage from the actual cable who was here to taking radio signals and actually creating enough current to drive it. Things you learn. This is debugging a hardware protocol. So we had some problems with the signals from the cable, so we had to start debugging it. And debugging is no different than actual normal debugging. You try something and you see if it works, and you're trying to find the errors. In this case, we know that we have too little resistance, and we didn't have any pull-down resistors to the actual cable. Now, pull-down resistors is basically something that pulls signals that are too weak to ground, so you don't get disturbances. Really simple stuff. There's also some links and some information about this in the band. Don't worry about it. Then we kind of cut it down to size, and we had a good, refactoring. This is the same thing. We refactored our hardware design, put it down to something nice. And then I realized I was going to take it on tour and go around Europe with it, so I added some glue. A lot of glue. Okay, please do not leave the room for the next 3 slides. This is really simple, but can scare web designers. So this is the original thing we actually had when we take it down. I'm sorry if I insulted any web designer. Please do not hit me. I know you're cooler than me. So anyway, this is the original design that we had in the product. So it was super simple. It was a resistor, a battery, and a switch. And we pushed it, and it transmitter sent the signal to the lovely little doorbell over here. And it made an annoying sound. So, yeah, shut up. So what we did was that we complicated it a little bit. So we added a cable to the button, so we can actually read with our brain over here, our microprocessor, is somebody pushing the button? And then we can react to it. What are we going to do about it? Well, one thing we want to do with our brain is actually being able to make it chime. So we added a transistor that you can see on the image. And all the resistors you see here, except for the one that you have from the white cable, are there to avoid noise. So please disregard them. They're there. You're not going to need them. You're going to need the 2.2 kilo ohm resistor to do exactly the same thing. Ooh, what was that? So it's still super simple, still really easy to connect, and really easy to transmit. But now, in the way of the button that we have over here and the annoying noise we make over here, we have a brain. And I'm just going to go to Visual Studio. Okay, so now what can we actually do with this brain then? Well, This brain is a Netduino. I'm going to talk about a lot of different hardware platforms for, so anybody who hates Microsoft technology, you can just relax. We're going to talk a lot about Linux and cool stuff in a little while. But I like this because you can actually program it with .NET. And it's actually really, really simple. So if you're some guy who knows electronics, he can set it up and he can take basically any .NET developer and he can write code for this. Because everything here is objects. Everything is objects. If we go to the doorbell, okay, so we have an output port chime pin. This is basically what we need to interface with the real world. So we have the chime pin, and the chime pin can just say true or false, which is, well, a logical 1 or a logical 0, and that allows us to communicate with the transistor. So we have an object that we use just like any other programming. The only difference is that this piece of the code actually affects the real world around us. So, allow us to demonstrate. Allow me to demonstrate. So this is the web server with the, I told you I'm not a web developer, right? So this is the web server. Nothing much, but it can actually reply with a basic standard web page. I can go into it, and I can hopefully give it a command like chime, or make, maybe I should call it make annoying noise. Anyway, this is annoying noise, and we're having a presentation here, so, well, please do not sound. So we can mute it. We give it the mute command. Now, this is, of course, really inefficient to have a web server doing this, but it's really easy for me to demonstrate it to you guys. We could, I assume there's app developers in this room? A couple? So how hard would it be to use this REST interface for a web, for an app? Pretty simple, I would assume. So we can do that. And now if we try to actually ask it to chime, well, it's nice and quiet. That would be cool. That's true, that's true. That would be cool. I will implement this idea. So, we have all this stuff. And, well, that's all there is to it. If we're going to zoom in a little bit. You can see here we decode the query parameters. We check if it's a command we can actually use, or else we discard it. And if it's a command we can use, we actually go into the doorbell object, which is a standard object, like everything else you've seen in your entire life. And we do this little simple piece of code. We define an output port, which is basically an object that holds the physical world. And we tell it, write 1. Does this sound complicated to anyone? How do you? We'll get to that in just a few moments. I'm going to talk a little bit about hardware, and hopefully I'm going to answer your question in a little while. You know what? No, let's do it now. So this one is connected in 2 ways. It's connected with a USB port, and it's connected with a network cable. I prefer network because anybody can use network. The USB cable is only here to allow us to communicate and debug. And we're going to demonstrate debugging in a little while. But we use network for almost anything. With today's modern protocols and stuff like that, network is super simple. Transfer and communication is super simple. Don't worry about it. So I'm going to get back to this in a little while, and we're going to show debugging and a lot of cool stuff. There we go. So, anybody who actually want to try this? None. 2, 3, 4. I've failed. All right. I hope I'm going to be able to commit a few more. Okay. So first of all, what do you need? You need a brain. You need to learn a brain, a preferred brain. One of my favorite things to tip about is the Arduino. This is like the run-to-the-mill, the first thing you start with. It's huge. It has such a huge community that it can make the .NET community look small, like really small. Like it has .NET people, Linux people. Basically everybody who's ever programmed and done something for hardware can tell you a little bit about Arduino programming. There is an Arduino group here in, I was going to say Kiev, I don't know why, Krakow, sorry. Here in Krakow, there's an Arduino group here just devoted to programming this microprocessor. And that's just kind of, it's huge. And it basically doesn't actually have a real disadvantage until you, like, when you're starting out. It's cheap, it's real-time possibilities, it's multi-platform, you can use Linux, OpenBSD, Windows, DOS. Yeah, DOS. I mean, that's kind of cool, right? You can use anything you like, even Emacs. That's an OS, right? All right, so, and basically the only thing it does have problems with is no multi-threading. It used to be, I haven't updated this slide, it used to have the possibilities it was like not really C code, but now they have an array of programming languages. I've seen people that has like, I think you have C++, full C++ support for this. So it doesn't really have to bother you anymore. And I'm a really good ANSI 99 writer in C. I didn't notice that it wasn't real C until like 2 months into a project. So it's not really that visible. So no real disadvantages and really, really, really good. So if you want to start out and you want to use Linux, this is my absolute recommendation. However, there are some of us who do like .NET. Some, I said. And then we have the Netduino. This project is showing here is built on a Netduino. And it has multi-threading, it has excellent debugging for Visual Studio. And that's one of the reasons it might be a good solution to actually use it, because you can debug it super, super simple. But else, however, you have to use .NET. And some people call it an advantage. I'd like to do that. Some of you might call it a disadvantage. But it kind of is both. Because, you know, you can ask a lot of people about now. You can go on Stack Overflow and have Jan Skeet tell you how to do stuff on a Netduino because it's .NET. So he can answer like a question, and people on Stack Overflow can help you. But you also have a really, really, really good microprocessor that runs in about the same speed as the average Arduino. Because it has like a lot of memory, it takes a lot of space on the microprocessor to have this, which is a drawback. Also the community, if you look at the Arduino community, the .NET community is going to look small. It's going to feel small. And that's kind of a bug. But it actually isn't, if you counter in that you have the .NET community to help you, it isn't really that small. Anyway, so let's get into JavaScript, guys, hardware platform. Raspberry Pi. This is actually one of the only platforms that are able to be programmed in JavaScript. I think there's one other microprocessor that you actually can program in JavaScript. I hope somebody, for the sake of the joke, has put it in a coffee maker. But this is one of the most versatile software. You can buy it anywhere, any hardware store. You can go in and just buy one. You can connect a keyboard and a screen to it and an SD card, and you can actually develop directly on the platform. And it doesn't actually cost much more than a base standard Netduino. If you want to use the .NET, you can install Mono, it's called Mono, yeah, Mono, and actually run C# directly on it. It doesn't support Visual Basic, though, which is a good thing. And it has a huge community. On the other hand, you can also see it as a disadvantage because it has GNU Linux. You have to have GNU Linux on it. And if you're wondering why I'm saying GNU Linux, it's because I fear that Richard Stallman might be in the audience. So you have to have that. And it's the GPIO support, the general purpose input-output ports that we're using here to actually communicate with our doorbell, aren't really 100% fully developed yet. They just released a revision B+ that is better, they've said, but I haven't had time to actually try and break one yet. Hopefully I'm going to have time soon to try and break one. However, since it's Linux in the bottom, you have a USB handler, USB host. So you can pair this one up with, say, an Arduino. So you can actually communicate with an Arduino with a short cable and use all the power of the GPIO ports on the Arduino with all the strengths of a Linux system for web services and stuff like that. And that together is a really, really, really cool solution. Also have a large community, supports plenitude of Linux distributions. So it's also a very good first start, good thing to begin using. Some of you might have tried, if you had a lot of people who owned one, you've tried and said, no, it doesn't have enough power. I want to do Bitcoin mining on it. So, okay, fine. You still need a lot more of these guys, but let's meet our BeagleBone Black. Anybody try this one? Oh, he's awesome, by the way. So, BeagleBone Black is like my personal little favorite. I haven't played around with it enough yet, but I'm hoping to get to do it soon. It has an ARM7, so it's a 1 gigahertz of power combined with the 700 megahertz of the Raspberry Pi. It has a huge amount of RAM, but what's really, really cool is the huge amount. And I'm going to read here now, because I don't actually have this memorized. It has 65 general purpose input ports, which is the most of any, of the standard microprocessing ports that you actually have. It has 3 I2C buses. It has CAN buses. It has SPI buses. 5 serial ports, 8 pulse-wide modulation ports. This is like a plethora of possible ways to actually integrate with something physically. And I really, really like this. I'm going to be around here for there's like a plethora of more software. I use a lot of ARM, but I'm not going to talk about that. So sorry for anybody who uses it. I'm not going to talk about STM32. I'm not going to talk about PIC or any of the basic micro platforms because I really don't have the time. So I still love you guys because you're doing it, because these are really hardcore stuff, but I don't have the time to talk about it. I do have after this if you want to talk about it, because I love it. So anyway, you want to shop? Go here. This link is going to be available on the online later. You can find all this stuff where you can buy it, suggested starting out packages for small transistors and diodes and anything else. How are we doing on time? We're good. What? 20 minutes. Oh, lots of time. Am I talking too fast? You guys get this? Awesome. So let's talk debugging. Back in the days when I started doing this, debugging was about as hard as crawling through the currently situation in the Syrian desert nude. You couldn't do it. You actually had, you put LED diodes everywhere. Okay, now I'm in that part of the code, so because that LED is actually lighting up. Okay, the next one didn't, but the third one did? What the? And you have to go around like that. And things have improved slightly since. Slightly. I said slightly. So allow me to unmute and send the wrong command. Here we go. So what we're doing right now is we're debugging a microprocessor. All the code is run over here. We're not doing an emulator. We're not doing any stuff like that. We're running directly from a microprocessor, and we're talking to it here. So we can actually go in and look at our object here, our chime pin. See all the information about it, all the initial states, everything we want to know. And we can also see our entire code. And we can run it. We can actually step the code. And as if you all are aware with Visual Studio, we can actually go back up and we can do it again. So it's come a long way. Now you can do the same thing on an Arduino, but you're going to need some more hardware. You're going to need an AVR Dragon, for example, to actually connect it. There are a lot of ways to do the same thing with Arduino. I don't really find it just as simple, but it's pretty simple. And that's one of the reasons why you actually should select one of these platforms to do something like this the first time you're doing it, to actually be able to look at, okay, what data am I actually getting into the software system? What am I getting? All right, so let's look at actually getting data. Because we've been able to transmit to this little one, and we've been able to mute it through this. But we also have a button that we can press and make an annoying noise. So how do we actually read data from the physical world? Well, it's actually just as simple to do this as it is to send something. Code. The difference is here that we define something called an interrupt. And an interrupt is very similar to an event. So when you're doing regular programming, you're doing event programming, you know, you bind something to a class. No, I mean to a function, sorry. And you can do the same thing here. So what we do is we define a switch port, our interrupt port, and this switch port here has an event called onInterrupt, which is flagged when we have an interrupt. An interrupt is when the port goes from ground connection to plus 3.3 volt that we have inside the button here. So from here, we've done 2 lines of code, people, and we have standard .NET systems. Now we can just do it event programming, and when we get our event triggered, let's check it out here. There we go. You see it? I'm gonna zoom in for you. We can just continue to do stuff like this. Now, this might not be as interesting perhaps on a doorbell, but if you think about this in a large-scale software system, we have a plethora of buttons, you actually have a physical functioning item in the real world. This is a lifesaver, because you can go in and you can, this could send the ID of the button. It has a resistor ID on it. We can have 256 here, and we can see, okay, that's the button we pressed. If we've done things, we send information to Google Analytics as an event. Okay, most people are pushing this button and selecting this option. Great, we have statistics for it. And of course, we can make an annoying sound. I was a bit worried there. What the hell? So, we have taken information from the microprocessor and sent it to this one. Was that hard? No, it wasn't. We've taken information from here, took it here, processed this. Is it muted? No, it's not muted. All right, send it. We've done all these things, and it's been really, really simple. And you want to know the dirty secret? It doesn't actually get harder. If we wanted to do a pulse-wide modulational output, that's a really hard word. Can we say it together? Pulse-wide modulation output. I like you. Anyway, that's something we can use to dim a LED, control a fan, something that needs a controlled amount of voltage. We can make it control by simply pulsing something in a high speed. All right. I'm lying a little bit right now, and the electronical engineer in the front row here knows that. But anyway, you can use it for such a things, and it's really, really easy. It's just an object that we define. We send information from it in the same way we've done this. 2 lines of code, and then it's straight swimming. And it's no difference if you use an Arduino. You just 2-3 lines of code, you have an object, and then it's standard C++ or standard C, if there's such a thing as a standard C. You with me? Cool. So who's going to try this? I love it. Now I have more hands. I actually have a Netduino with me here. So if there's somebody who's a .NET developer and asks a really good question, I'm going to give it away. Hello. Thank you. Oh, bollocks. So, I'm not out of time. I'm actually having, I must have talked really fast today. But this is my contact information. This is my email, my Twitter. And if you want to cheat, you have to have a technological problem of an electronical kind. A lot of the people that know me on Twitter are really good at electronics. I'm not, but they are. So if you send something and I reply to it, and it's going to be wrong in one way or another, they're going to come in and they're going to give you like this answer. No, it's like this. So it's a really good way. I can just write anything, and they're going to come in and, no, you're wrong. It's like this. So it's excellent. Any problem, just do that on Twitter, and somebody will sort it out for you. This here is my blog. You can find all the information from this talk. You can find all the slides and everything. Convert to it. There's also basic instructions how to do anything to get started with this sort of programming. The slides will be up later, so you don't have to document if you don't want to. There's also some credits, because I stole some images from the internet, but they were free if you gave credits, so I'm giving credits. So I'll happily take questions. I'm sorry? That's an excellent question. In fact, there's a story. There's a man, he had a house, which was a smart house that he built, or bought. And his wife divorced him and got the house. And moved in with his new boyfriend in this house. So anytime they went away for a holiday, he raised the temperature to sauna levels. Sauna is a really hot place, you know. So he just raised the temperature up, and when they came back, he just lowered it down as far as he possibly could, so it's freezing inside when they came home. So he was not only controlling their bills, he was making this a really, really horrible place to live. And this is something that we really have to figure out. How do we do security? And, well, this doesn't need security in that much, because it's not that annoying if somebody's like muting your doorbell. It's not a big problem. But when he says, what if we scale it up? What if we build a really large system? What if our neighbors decide to actually hack us and do something with this information? Yeah, it's a really big problem. And I don't actually have a good answer. I mean, I have probably, how many guys are you in here? 100? 80? Technology expert here. We can probably find a good solution, but we don't have one right now. Because the IoT development hasn't really reached those levels yet, where this is a problem. So I would happily give you an answer, but it's not going to be the right answer. Something we can talk about is that there is basically I'm using a web platform here, which is wrong, about as wrong as using JavaScript for hacking hardware. You're supposed to use a centralized server with security, which has separated communication platforms with MSQTT communications, like packet communications that can actually be authenticated and not easily hacked in such a way. But the thing is, I think a lot of people is going to produce really cheap stuff like this, which is going to have bad security, and this is something that we are really going to have to look into in the future. Sorry I couldn't answer your question better than that. You, sir. I think they actually, another Beelboom Black does. I'm quite sure that the Raspberry Pi does. Anybody know that? Can confirm? Yeah, it does. The NetWiener 2 does that, and I can't actually. It depends on which chip you select, because with the Arduino, you don't often buy an Arduino that has thank you, an internet connection. So you actually add a shield to it. Allow me to go back a little bit. So if you look here, you can see there's a black connection point to this one, and above the one, and the second one from the top actually has like pins. So these ones connect into each other, and you add functionality that way. So you will have to find a shield that supports IPv6, which exists, but they're more expensive than the ones that support 10 megabit communication and IPv4. But again, like I told this man earlier, we're not really supposed to do multi-scale communication in a larger product that way, but rather perhaps a wireless communication of really small packets into a system that then handles the addressing system. So I don't think we're actually going to connect network cables to everything, but rather small wireless communication platforms, radio frequency. Does that answer your question? Thank you. Yes? Yeah, absolutely. You use these for product, but every one of these are open source, so you can just build your product around this type of hardware. So you can have the same type of hardware, same type of inputs. The Arduino is very common to do so. Sorry, but actually, the question is also that this is very expensive to do in a production system. We have a system where we built a security house for an entire building that they wanted really specialized security because they wanted to be able to open doors to specific parts of the location, but just the doors that are required to reach this location, which is actually quite challenging when you start to look at it in the big picture. And you have, this was a place where you play music, so they had a lot of expensive stuff also in here. But what you did here was we did all the prototyping, all the development on these items, and then we built something around them and kind of included the design in our finished product. More questions? How about time? All right, are there any more questions? Yeah. Oh, absolutely. Oh, this is a good question. Of course, cloud services. This is a whole talk, actually. We've done loads of this stuff. How many Azure developers do we have today? Oh, lots of Azure development. I love you. And we have also any other cloud platforms? This is actually really effective. We use these all the times with Google Analytics. We use them with Azure, and you can do so much stuff with this. So we actually put this in our office. So we put 4 buttons in our office. So 4 buttons, like how much did you look forward to coming to work today? It's a small sign. So red, yellow, a blue, and a green button. Okay? So you come in and it's like, oh, I'm not liking it today. Boom. Or, yay, I'm coming to work. So boom. And then we upload it to Google Analytics because we're just a simple event. So every day we can in real time see how much were our personnel, how much were our staff looking forward to coming to work today. And you'd think this is a balanced piece of software, but it's actually really, really useful because anytime we make a change, you can see that it actually goes up or down. And otherwise, it's actually really, really consistent. We thought it was going to be all over the map because, you know, people have kids, they don't sleep well, they're hungover, you know, anything like that. But it's actually really, really consistent data until you do an active change in the office. And that's where you start to notice, like, oh, hey, something like that. And we're right now moving this solution because we really love this solution, so we want to upscale it. So we thought, okay, let's add an app. So we have this really good Xamarin guys who do app development for all platforms. And we're going to move it to Azure as well right now. And at the same time, I was talking to Microsoft Sweden. And Microsoft, I hope I can talk about, yeah. Microsoft has a new IoT thing where they have actually the MQTT protocol. So you can connect small microprocessors, talk with an IoT-enabled framework to the Azure device, and then exponent it from there. So Azure is really coming, so I think it's actually a few months just, and they're going to actually release this to the public. So Azure is really going to have a huge and great IoT support in a matter of months. So you're going to be able to build for. And it's really, really easy to actually do it. I mean, you have the entire .NET in these. You don't have refactorization. It's really simple stuff, really advanced stuff, but you have all the basics here to actually communicate with Windows Azure. So it's the way we do stuff today. You don't want to have a bulky server somewhere. You want to have it on Azure, as long as you can get people to understand it's secure. Nope. You can do it with a Raspberry Pi. You can do it with a, I don't know if you can do it on Arduino, but you can do it with anything. You can do it with a PC. Anything that supports the MQTT communication framework, you can do it with. And that's an open framework. It's not something that's just supported by Microsoft. It's not even invented by Microsoft. It's an open framework. You also have open source hostings for this. Just Google MQTT and you will find loads of them. And you can host your own and do real big solutions about this. But that's a whole other talk. Did that answer your question? Thank you. I'll have a Raspberry Pi. I'll have a Netweener for you later. If there are no more questions, So, smart technology consumes a lot of powers. What are the current ideas to actually solve this problem? Well, you have a lot of new processors, not these ones that are built for prototyping, but you have a lot of new processors. that are built for actually being very smart in power consumption. One of these comes from Texas Instruments, is MSP430, which with 2 superconductives actually can hold a process of counting up from 1 to 9 on a display for up to 3 weeks. And I think it's actually just the display that died after 3 weeks, and it continues to actually work something. And this from an original charge to 2 superconductors. It's super, super power efficient. Then you also can use something called sleep mode on these processors. These processors can actually, if you have something that isn't necessarily live all the time, let's say we want to check our flower pots once a day, like how much water do they have? Well, we can configure it to wake up 1 time every 24 hours, 1 time every 12 hours, do our measurements, transmit it, and then just go back to sleep and drain a minimum amount of power. That's one way. Also, for the third part of this, we also started using stuff like, I'm going back to MQTT again, because anything, it requires as little data as possible to transmit things. Because if we would use a web server, I mean, of course, it's going to drain a lot of power. But this is mainly for the demonstration in this room today. But rather, we would use MQTT and transmit it to a server. So that's what we're doing today. And of course, people are also researching to create even more less power consumption microprocessors. And I think the MSP430 is the best one right now, but it's also really, 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 well, I mean, power consumption comes at the cost of processing power. So you're going to have that as well. Anything else? Yes?
Did MQTT get an update or something? Because as I remember, it's a really simple protocol, and there's no security enabled inside the protocol.
Yeah, they said that there's no security in if that's true. You have to implement that on the processor, and you have to implement it on the thing that's actually getting the package. There's nothing supporting not implementing packages inside the stream if it's possible to do that. Some ways to solve this is to have transmission on specific times, a synchronized watch between the items that are not based on a regular clock, so that you have to know specifics about each device to actually be able to. But all of these are easily hacked, and like I told you earlier, we don't have actually somebody probably has a really good solution for this, but I don't have a really good solution for this insecurity. Oh, my battery's running low. Good. So that's actually all I had. So I thank you. Thank you for listening.